When we have data, lots of data, we store it in files. Now, so far, we've been keeping data in our program with variables like arrays and vectors and strings. But when we talk about files on a computer, we're talking about data that's stored outside of the program that we're writing and outside the part of the computer's memory that holds the program that we're running. That is, a file is something that is located and saved in a long-term storage area. It could be on a hard drive, or a solid-state drive, or in flash memory, or even over a network in the cloud. The memory used to store files is also generally a lot cheaper than main working memory, and so it's possible to store much more information in this longer-term storage. Of course, we work with files all the time. The programs we write are themselves stored as files, just like our pictures, music, spreadsheets, and so forth. But the files we'll care about here are those containing data. Data that we want to either read into our program or data that we're writing from our program. The C++ methods we'll learn in this lecture allow our programs to become much more powerful. We'll see how the streaming techniques that we've already been using to read and write from the console will apply to reading and writing files. And the same techniques can even be used for reading and writing strings. Streaming turns out to be a nice, general way to handle a wide variety of input and output. Now, if you've been using only a web browser-based C++ editor to run programs so far, this is the time to download an IDE, an integrated development environment. Web-based compilers are not likely to let you just create, read, or modify files on their system. So, to try what we're doing in this lesson for yourself, I recommend that you download and install an IDE, whether Visual Studio to a PC with a recent version of Windows, or else download and install Xcode to a Mac with a recent version of the Mac OS. For more details, see the Quick Start bonus segment at the end of Lecture 1, or consult the supplementary material that we've made available online. Now, before we get started, I also want to clear up one misconception about files and file types. Every file on a computer has a name, followed by a period, followed by a short combination of letters called the extension of the file. A file ending in .pdf would usually be a file in the Adobe Acrobat PDF format. A file ending with .dat would usually be a file for storing data, and so on. A file ending with .cpp indicates that it's a C++ program. Now, where some people go wrong is in thinking that just by changing the extension, you change what the file actually is. And that's not the case. If we take a word processing document and we change the extension to be an image extension, it doesn't magically transform into a picture. If you create a file, make sure that the extension accurately reflects what type it is. Okay, whenever a program is reading or writing to a file, it always involves three main steps. First, opening the file. And this will involve some special syntax and commands. Second, we'll read from or write to a file. And these commands will look very similar to reading and writing with the console. And third, we'll close the file. And this will actually be really simple. We're going to need to use a library, fstream, that gives us the tools to write to a file. Fstream is short for file streaming. And just like we were able to stream console input and output using IOStream, now we'll stream to and from files using fstream. Once we have the fstream library included, we can create variables of the type fstream. Now, when talking about variables, I'm going to start using a term, object, that we'll see more and more of as we go along. You can think of an object as being like a variable, and we can sort of use the words interchangeably. We'll use terminology like declare an object or initialize an object, just like we did for other variables like integers. But saying object actually implies a little bit more than what we've been talking about with variables, since an object can store more than one piece of data, and it also has functions that belong to it. We've actually been using some objects already. Vectors and strings are objects. Remember how they had functions like pushback or size that belonged to them? Well, when we talk about variables of type fstream, we often call them objects because they also include their own functions. So, to create an fstream object, we just declare it like we have other variables. We give the type, fstream, along with the object name. And in this case, we name our object my_file. Now, to actually use the file, we need to link up the object name that's in our program with some file that's stored out on the computer. And we'll do this through an open command. There's a simple version that I'll discuss first, but in most cases, it's better to use the longer version of the open command. For the simple way that we get a file to open, we write the fstream object name, then a dot, then the word open, then in parentheses a string giving the file name. And the file name should be the name of the file in the computer itself, the one we would see if we opened up a file explorer. Unless the file is in the same directory as your program, be sure to include the path information as part of the file name. In the example line of code here, the fstream object is called myfile, and the file name on the computer is test.dat. Now, the longer version of the open command also asks us to specify how we want to work with that particular file. To read or to write, that is the first question. If we're reading, it's straightforward to open the myfile object. That's just myfile.open, parenthesis, file name, parenthesis, semicolon. But writing to a file that's already on the computer can have 2 or 3 different interpretations. One option is that we leave everything in the file there, but we overwrite it 1 character at a time. Another option is to leave everything in place and have everything that we write added on to the end. And a third option, sort of like an old Etch-a-Sketch, is to delete everything already there and start writing to an empty file. Now, to specify which way to use the file, we'll use some special syntax. When we open the file, we'll give not just the file name as an argument, we'll have a comma, and then a second argument, starting with fstream::, which describes how we want to use the file. There are actually 6 different options. Read as input, output that overwrites 1 character at a time, append, truncate, the @end form of output, and binary. And we can use more than one. The code for these are in, out, app, trunc, @e, and binary. The reason each of these options starts with fstream::, is to indicate that they're in the fstream namespace. For example, if we want to open test.dat just for reading in as input, we'll call open with both test.dat and then fstream::in as arguments. Out will open for writing. Unless combined with trunc or @e, any existing data in the file will be overwritten. Append will mean that we're going to write output to the file, but only after whatever's already there. Nothing gets erased or deleted. Truncate is combined with the out option by using a single vertical bar. Truncate means that we should delete whatever is already in the file and start writing from scratch. And we can only use trunc if out is also specified. @end writes at the end of the file, usually with the same effect as for append, but with some ways to move around in the file after you've written in one place. @e should also be enabled along with out, using a vertical bar in between. Binary can be combined with any of the previous options, using a single vertical bar. Specifying binary means that we'll be outputting just 1s and 0s directly. Binary is a more efficient way of storing data, but it means that people won't be able to open up a file and look at it as text. Most commercial file formats will use binary for its efficiency, but casual programmers will stick with standard text. Now, compare all of this with the simple version of open, where we just used the file name. Well, the simple version opened the file for input, and if there was already a file, it was opened for output. However, it can't create a new file if one didn't already exist. Basically, whenever you open a file, it's a better habit to always write the open command to include the way that you're wanting to use the file. No more and no less. And that way, there's never a question when reading the code about how the file is supposed to be used. Now, we can initialize file stream objects when we declare them. And this is just like how we initialize other variables, by setting them equal to a value when we first declare them. We do this by putting the information that we would put in the open function into parentheses that follow the declaration. Then we don't need an open statement. So, the two pieces of code that you see here are basically equivalent. The first one declares a file stream named my_file, and then opens it for input, linking the object in the program to the file test.dat. The second piece of code does the same thing, but it eliminates the open statement to put everything all in one line. Now, when we initialize an object like this by specifying parentheses and arguments when the object is declared, we're using something called a constructor. Let's try a quick example. Say that we had a file named accounts.txt, and we want to write data to the end of that file, keeping what's there. How could we create an object named datafile in our program that lets us write data to the end of our accounts.txt file? We have a few options. See if you can come up with one. Well, to work with a file, we need to start with fstream to declare a file stream object. One way is to declare our data file object and use a constructor to initialize it all at once, using the append option. We would write fstream datafile, open parenthesis, quote, accounts.txt, quote, comma, fstream : app, close parenthesis, semicolon. Remember that the fstream : app means that we're appending onto the end of an existing file. Or you could use the open command separately, again with the app option. Another option would be to declare the data file object first, and then on a second line, use the open function to open it. So here, instead of the append option, we could combine the out and the @e options to say that we're writing, starting from the end of the file. And that gives us ways to move around in the file after we've written in one place. Or you could tighten that up to a single line, using a constructor with the out and @e options. All of these basically work the same. Okay, so at this point, we have an fstream object declared, and a file has been opened. Now, we can use that fstream object to stream to and from the file. And this works exactly like cin and cout worked for the console, except instead of writing cin or cout, we just use the name of the fstream object. Let's say that we want to write some information about a bank account to the file, like a new account that we opened. We could start by declaring an fstream object named myfile. And to output, we can just write myfile, stream operator, the string we want to output, stream operator endl. And the stream operators will point toward myfile. Since the data is flowing into the file stream, the string giving the bank information is flowing into the file that's linked to by the myfile object. Now, once we're done using a file, we should always close it. Closing a file ensures that everything is written to it and it's left in a valid state. Now, if you forget, things may be okay, but something you thought you wrote might not get in there, or the data might appear corrupted overall. Closing is very simple. We just take the fstream object and we call the function close that is a part of it. That is, we have the object name, then dot, then close, and parentheses, and of course a semicolon to end the line. So, now let's look at a complete program for working with a file that has a grocery list. We start out by pound including fstream. Now notice that since this program is not using the console, we don't even need to pound include iostream. In the main part of the program, we declare an fstream object named groceryFile. We then open the file grocerylist.dat, associating it with our groceryFile fstream object for output. Now we can output to the file by streaming output to groceryFile, just like we would have done for cout. In this case, we've streamed 2 lines, one with skim milk and the other with eggs. And finally, we close grocery file. If we go out to the file system, to the directory where the program was executed, we'll find the file grocerylist.dat there. And we could open up that file in any text editor program like a word processor. And we should see 2 lines of text, skim milk and eggs. Now, streaming output to a file is just like streaming to the console using cout. And streaming input from a file is basically just like streaming from cin. So, say that we've got a file, grocerylist.dat, already written, maybe having written skim milk and eggs to it, using the program we just saw. Well, we can create an fstream object, and just like before, open it with the input option. Then, we create a string, s, and we stream from the file into s. So we write grocery file double greater than s. When we print out s, what do we get? Well, we get skim. Notice that we read in a string, so we just got the string until the first white space character. Notice that we also had to pound include the string library and the IOStream library, since we end up printing something to the screen. Now often, when we're reading information from a file, we'd rather read in an entire line of the file at once, rather than just a single word. And we can use the getLine function to get an entire line. As discussed in our lecture about strings, getLine is a function that takes 2 parameters, an input stream and a place to hold the result. In the past, our input stream was cin, but now we can use the fstream object as our input stream, and we hold the result in a string. So for this program, we could replace our stream operator with getLine, open parenthesis, grocery file, comma, s, close parenthesis. And if we do that, we get the entire line, skim milk, from the file. When reading from a file, we often want to keep processing through the whole file. To check whether we're at the end of the file, we can call a function EOF that belongs to the fstream object. Now EOF doesn't take any arguments, and it returns a Boolean. If we've already hit the end of the file, then it returns true. Otherwise, it returns false. The EOF function is helpful in a while loop. We can set up a loop that continues until we reach the end of the file, where EOF function is going to return true. That's while not myfile.eof parenthesis. And this loop will thus read every string from a file and output it to the console. Now, there's one thing that can be tricky when using EOF. The end of file is not true when you read the last thing in the file. EOF will still be false after reading that last item. Only after we've tried to read again and there's nothing left to read will EOF be true. So in this case, notice that we try to read a string in from the file before we get to the while loop. Then we read a string again as the last thing inside the loop. So either way, whether we're checking the while condition for the first time or we're checking after completing an iteration of the loop, we're always trying to read a string just before we check EOF. That way, if we fail to read a string, we'll see that EOF is true when we check. Now notice that this while loop is basically a for loop. We have an initialization step where we read in one string. We have a condition, making sure that EOF is still false. And each iteration of the loop, we read in one more string. So we can write this code using a for loop, which describes how the loop behaves in just one statement. Let's try a couple of practice programs. Can you write a program that will generate a file containing your name and address, and call the file address.txt? Well, here's what that code might look like. We'll be working with files and strings, so we pound include fstream, and we pound include string. And we create an fstream object, which is going to be linked to our output file. So I called it my file, and I initialized it by opening it to the file address.txt and designating that we'll be using it for output. Then we output 3 lines of text to the file, just streaming out some strings. And finally, we close the file using .close parentheses. Okay, that was generating a file. What about a program that will read from a file named balances.txt and then compute and output their average? Suppose we're using floating point numbers. Well, here's one way that you could write that program. First, we open up the file for input. And in this case, the object name I chose was bank file. We'll be reading in floating point values f from the file. We'll keep track of a total, and we'll keep track of how many values we read in with numvals. So, we declare all of those variables. We initialize both the total and the number of values to 0. In order to read through the file, we'll use a for loop, similar to the one that we saw earlier. We initialize it by streaming a value from the file into our floating point variable, using the EOF check as our condition. And we read in a new value each iteration. So, inside the parentheses, that's bank file, stream operator into f, semicolon, exclamation point, that's a not, bankfile.eof parentheses, semicolon, and again, bank file streaming into f. Inside the loop, for each value we've read, we add it to the total, and we increase the count of variables by 1. And at the end, we close the file, and we output the average to the console. And either order would have been okay for those 2 commands. Now, in C++, the concept of streaming means any way of making data flow into or out of something. So, there are other ways to stream that don't involve files or the console. And in particular, it turns out that we can also stream to and from string variables. Now, this can be very handy. It lets us store data in a string, similar to the way that we'd store in a file, but without having to actually put a file out on the operating system. And it lets us avoid nagging users for sentinel values when they've finished their input. We can create a string by using streaming operations. And we'll write to a string like we would to a file. Or we can also stream in from a string, processing the data contained in a string like we would the data from a file. To stream in and out of strings, we'll need a new variable type called a string stream. We've had int, float, bool, and we've had vector and string. We'll now add string stream to the list. It's a type of variable that links a string to the streaming operations that we've been using. So to declare and use this new type of variable, we'll need to #include the stream library. Notice the pattern. IOStream was for input-output with the console. FStream was for files. SStream is for strings. The string stream will provide a link to and store a particular string. And this is very much like how the file stream links to a particular file. But the string stream also stores a particular string. And just like when we wanted to read or write a file, we streamed in and out of an F stream, well, when we want to read or write from a string, then we'll stream in and out of a string stream. Data that we stream in and out of the string stream will be written to or read from the string that is stored inside. So, if we're going to stream data out of a string stream, we need to give it some initial value. That is, we need to tell that string stream, there's a starter string that you should be using. And there's a built-in command, str, for specifying the string that we want to use as the default value argument. Let's look at a short program that reads in one word from a string to illustrate. Now notice in this program that we #include stream at the beginning. The type of variable we declare is this new string stream type variable, and the variable name here is simply word reader. Okay, we have a variable of this new type, and we need to initialize it with some particular string. In this case, I've initialized WordReader with the string apple, banana, cherry. Now, the general form for streaming doesn't change, whether we're using cin to get input from the console, or using fstream to get an item from a file, or using stringstream to get an item from a string. So, let's say that we want to read in some string variable that we've named firstWord. We can stream from WordReader into firstWord. That is, WordReader stream operator into firstWord. And this will read in the first item from whatever string that WordReader holds. That is, the text until the first white space is read. So that is then assigned to firstWord. In this case, the first thing before a white space is the word apple. So our output verifies that indeed the word apple is what's been assigned to firstWord. Now a string stream can also be initialized with a constructor, similar to how we initialized a file. In this case, when we declare the string stream named WordReader, we just add parentheses with the string that we want to initialize with inside of those parentheses. Now, we can also stream output to a string. We just declare a string stream variable, and then, just like we could use cout to stream to the console, we can stream output to that variable. Inside of the string stream variable will be a string, and that string will get whatever text that we stream into it. Now to actually get to that string, we again use the str command, but this time with no arguments. We'll just write .str parentheses. Let's see an example. In this code, we create a string stream, address. We then stream output to address, just like we would have done to the console, cout, or to a file. In this case, we'll stream out 3 lines of output. Now notice that we can stream out text or numbers just like to any other stream. So here we're streaming out the zip code of the address as a number. To actually see the string that we've created, we have to get the string out of address by calling str on address. That is, we'll write address.str parentheses and assign that to a string variable. If we print out that variable, we see that it contains all 3 lines in one string. And as we did for the files, you can also use the so-called end-of-file function on a string stream. How it works is, when we've read the last character in the string, then EOF will be true. Now that's a little bit different than files, where we had to actually read past the end of the file before EOF would return true. But EOF can still be used to go through all of a string stream when you're processing it. Now, for simple programs, we could have created a string some other way, by just concatenating strings. But then we'd have to manually convert our data to strings and use concatenation rather than getting to make use of the nice stream operators that handle a wide variety of data types automatically. String streams let us more easily process large amounts of output, say a giant string that holds a whole page of text that we'll process and build over the course of a program. Or we can use strings to handle large input, bringing in lots of data like a file, and then processing it gradually through the program. And by processing from a string, we can avoid the need to have sentinel values. There's no need to make someone enter an artificial value to end input. They just end the line when they're done typing. So let's see how that would work, processing an entire line of text without a sentinel value. How about you try to write a program that first asks a user to enter a bunch of integers on one line, separated by spaces, and then reads that whole line into a string. Then it should pull out each number from that string separately, outputting them one by one. Remember to use EOF to find when you've reached the end of the string stream. These are similar actions to what you'll often take when processing data coming in from a file. You read an entire line and then process it piece by piece. Okay, here's one way that might look. Notice that we first prompt the user to enter integers on one line, and we read this into a string using the getLine command. In this case, I named the string input line. Then we create a string stream, which in this case I called string input. I used the constructor to initialize it to the string that I just got from the user, input line. Then I'll go through a loop until I've reached the end of the string stream. That is, I'll continue to process until stringinput.eof is true. I write this as a while loop. While, open parenthesis, not stringinput.eof parentheses, close parenthesis. Inside of the loop, I'll stream the next value from the string and output it to the console. That streaming operation is just string input streams to val, where val is a variable declared as an integer. Now if we run this program and we enter something like 1 space 2 space 3 space 4 space 5, we'll indeed get 5 lines output showing each of the numbers. And notice, we didn't have to bother the user for a sentinel value. Streaming operations are a very general and flexible way of moving data around, whether to and from the console, or using a string stream variable, or, most importantly, moving data in and out of files. It's streaming that allows us to handle larger files and read in significant data, not just things typed in from the screen. In our next lecture, we'll look at applying the skills we've learned here to design and debug a program for processing a larger data file. See you then.